I would like to go to the last part of our lecture today, okay? The example one. So let us read the questions and try to solve the example. Right. A 20 mld water treatment plant. So imagine you have a 20 mld water treatment plant has two mechanical flocculating tanks. So they have two mechanical flocculating tanks and each having a retention time of 35 minutes. So imagining that we have two mechanical flocculation tank and each of them, the detention time or the retention time is 35 minutes. Based on the information below, answer the following questions. Okay, the length and the weight ratio is 4:1. Okay, the depth of water in tanks, the depth of the water. Okay, let's say you have a flocculation tank like this. So the depth is actually 3 meters. The length and the width. Okay, the ratio of them is 4:1. Hydraulic gradient 50 per second. What is hydraulic gradient in symbol? Anyone know? Can I have some voice, please?
G.
G, thank you. Okay. So the hydraulic gradient is G. And then dynamic viscosity, what is that?
Mu.
Right? Velocity of pedal, 0.4 meter per second. So what is that?
VP.
VP. And the coefficient of drag, 1.8.
CD.
CD, right. Okay, so it seems that everyone understands that. And we try to solve the first part of the lecture, which is to determine the length and the width of the flocculation tank. So I have already extracted whatever information that you got from the example one into a figure. Okay, like that. Okay, you have two tanks. So you have the Q, which is the MLD, the flow rate, if you like, okay, 20 MLD, and that's divided into two mechanical tanks. And it says that the width and also, okay, this is wrongly labeled, okay, the width, the length and also the weight should be here, okay, not here. Please forgive me. I can change it now, right? My one is that's interesting. Solve already, right? Okay, the ratio between the length and also the width is 4:1. The depth of the water is 3 meters. The detention time is 35 minutes. And then this is your G, the mu, the VP, okay, the velocity of paddles, and also the CD is also there. Okay, so the first question they were asking you on to determine the length and the width of the flocculation tank. Okay, we'll have to determine the length and the width of the flocculation tank. Right. We would like to find out the length. Okay, that's the purpose of the first part of the question. They were asking you to find out the length and also the width. So you have already got the depth. So if you can find out the length and the width, okay, basically you'll be able to find the volume. So it'll be interesting if we can find the volume first. Okay, so how do we calculate the volume? Okay, volume of each tank is symbolized with this triangle of this V is equal to Q and T. Do we have the Q? We do have the Q. The Q was 20 mLD, okay, and the T was 35 minutes. Okay, but you have to remember it is divided into two tanks. So this Q has got to be divided into two as well. Okay, so 20 mLD divided by 2, you get 10 mLD. Okay, so your Q now is 10 and your T now is 35 minutes. So that would be 20 divided by 2, which is 10 mLD times 10 to the power 6 liter per day times 35 minutes. So I'd like you to solve that to obtain it in meters. Yeah, I'll help you a little bit, of course, okay, without any doubt. So those are the Q, and this is the time, the T, and then you have to times with 1 meter cube divided by 1000 liter. This is basically to change the unit from liter to meter cube. Okay, so you can cancel liters here. Then this is the meter cube. And then you have to times with all these values, okay, just to make the units the same. Okay, basically 35 minutes cannot simply times with day, so you have to do some conversion units. Yeah, that's what I'm trying to say. Okay, these are all for conversion units. Has anyone got the volume?
24306.
243.0555 non-stopping and something like that, right?
Yes.
That's right. Okay, 243.056. Okay, can I proceed?
Sure, counter.
All right. Okay.
Okay.
Right. The volume is actually depth times length times width. We have already known the depth, which is 3 meters. Okay. So the length and the width, let's width be x, and hence the length is 4x. So the volume is actually 3 meters. This is the depth times 4x squared. Okay, the length times the width, 4x times x. So you got 4x squared. So 3 meters times 4x squared is actually 12x squared meter. And this value is equal to 243.056 meter cube. So it's a matter of solving this x. Okay. So this value divided by 12 and then you square root it. So you'll be able to find out your x or your width. So find out your x or find out your width. Then find the length of the tank. Anyone have already got the answer?
4.5
0.5 for what?
meter. 4.5
The length.
for weight.
The weight is 4.5. That means the length is
18.
18. Yes, it seems correct. Okay, 4.5 for the x and 4x is 18. So hence the length is 18 meters and the width is 4.5 meters. So that's correct. Great. We look at questions B. Calculate the power required for each tank. The power required for each tank. So you remember power, there are two formulas. It's either this formula or that formula can be used. You don't have to memorize them. As I mentioned just now, it will be given in the exam, in the test, so you don't have to worry on that. So now we just have to plug in the number. Okay, so just let's try the first equation now. P is equal to G. Do we have G?
50.
Yes, we do have the G. Okay, it's 50. And then do we have mu?
Yes.
Yes, we do have the mu. Okay, which is some
0.798
yes,
times
someone,
10
yes, someone memorized that. Thank you very much. Okay, and then the volume is we have just calculated it. Okay, 240 something or something, right? So it seems to me that this formula is enough. Okay, this equation is enough for us to obtain the answer. So we just plug in all the number inside there. So P is equal to G squared. G is 50 squared. Mu is this is the volume, the value. Okay. And then the volume that we've just calculated, 2.43.056 or something. Okay. It has to be put 0.56. I change it. And then there you go. That's the answer. Okay. And the answer is 485 watts.